All right. If x is -7, negative x means the opposite of x. So what's the opposite of -7? Well, the opposite, if you have -7, the opposite of that would be +7. There's your answer. All right. For this problem, the perimeter is p. So you understand p goes there. Here's your function for the formula. What is the perimeter? What's p if the area is 36? So hopefully you understand that I'm putting a 36 right there. What is the square root of 36? So I have 1/4 times p equals 6. So the question then becomes 1/4 of what would give you 6? So I would go one by one. Is a fourth of 9 6? If I take 9 and divide by 4, does that give me 6? No. If I take 12, is 12 divided by 4 equal 6? No, isn't 12 divided by 4 3? Okay, so if I put a 12 in there, 12, 1/4 of 12 is not 6, it's 3. So far I crossed those two out, right? Next, 24. What's a fourth of 24? If I took 24 divided by 4, does that equal what? 6. Is that what I want? So there's my answer. That is one way by plugging values in. The other way is, could I simply solve this equation right here for p? Watch this. Watch carefully. I could have just done 1/4 p equals 6. Could I technically have multiplied both sides by 4? Oops. Could I multiply by 4, multiply by 4? That cancels, so p equals 24. There's no canceling on the right side. Okay. So this would be times 4. So p equals 24. There's two ways. You can solve it, or you can plug numbers in to get the right answer. If I want to find the reciprocal of this, all I do is flip it over. The y goes to the top, the ax squared goes to the bottom. Which would that be? D. All right, you guys, I want to know which set of answers make this true. So let's just plug that number in. Ready? Plug in -3 here. So the absolute value of -3 minus 3, is that less than 1?
Yes.
So what's right here? What's -3 minus 3?
0.
No.
But because it's
-3 and another -3 is -6. So this would be the absolute value of -6. And what's the opposite value of -6? Positive 6. So that is 6 is less than 1. Is that true? Is 6 less than 1?
No.
So that is false, correct?
Mm-hmm.
So can I also cross out this one because -3 is part of that group and I already showed you it doesn't work. Okay, let's go to the 3. Can I plug in this one?
Yeah.
All right, let's try it. If I do it over here, give myself some space. There's that one. Can I do absolute value of 3 minus 3? Is that less than 1?
Yes.
What's 3 minus 3?
0.
And the absolute value of 0 is 0 because there's no number.
Yeah.
I mean, 0 is a number, but there's no value. So is 0 less than 1?
Yes.
So is that a possibility?
Yes.
But it's also there, right?
Mm-hmm.
So could it be either of these?
Yeah.
Could I test one of these numbers and see if they work?
Yeah.
If one of these work, isn't this missing some other numbers that should work?
It's D.
So let's try D real quick. Which one of these numbers is easiest to plug in?
0.
Would you say 0 would be easiest?
Yeah.
I'm going to try that one right there. So I'm going to go up here, leave some space. I'm going to go to the absolute value of 0 minus 3. Is that less than 1? Let's see. What does that equal? Doesn't that equal -3?
Yeah.
So what's the absolute value of -3?
Oh, never mind.
And then become positive 3?
Yeah.
So is 3 less than 1?
No.
No. So what I just found out is 0 doesn't work, right?
So
if 0 doesn't work, that set's wrong. So is the answer that out of elimination?
Yeah.
I know that 3 works. I know 0 doesn't, so I can't use that because that's a non-working piece. This is a non-working piece. So there it is out of process of just eliminating choices. For this problem, I want to know what makes this equation true. So I'm going to plug in numbers. I'm going to start just plugging in 0. That's the first number in the first choice. When I plug in 0, if I put a 0 right here, what's the absolute value of 0? 0. So what's 3 times 0? Well, isn't that 0? Does 0 equal 15? No. So could I cross off 0? Can I cross off 0 every time I saw it?
Oh, wow.
Whoa, that means this doesn't work, this doesn't work, this doesn't work. I don't even have to check -5 and 5. I'm assuming they work, because nothing else works. There's my answer. Isn't that kind of slick? Now, could we test 5? Yes. Could I go 3 times -5, sorry, absolute value -5? Does that equal 15?
Yes.
And you put in +5, it'll also work. You could test that they work, or you just notice the zeros don't work, and bam, your answer. Booyah. All right, when I plug in numbers for x, I want this to be a true statement. So let's plug in 0.25. 10 times the absolute value of 0.25. Does that equal 2.5? Well, hopefully you realize when you multiply these two, it moves the decimal over this way, which would be 2.5 equals 2.5. So I know 2.25 works. Do any of the rest have 0.25? No, that's the answer. Since none of the rest have that as a choice, and that did work. Now, technically, when I put in -0.25, will that work? Because wouldn't -2.5 just become a positive because of the absolute values? And then 2.5 times 10 will be 2.5, which they match up. So my answer is A. Right off from the bat, you plug it in at work. If it didn't, you go to the next one. For instance, if you plug in 4, what's 4 times 10? 40. That's not that. 4.5? No, that's 445. No, I mean, none of these will work. This looks like it might work. But what's 25 times 10?
250.
That's 250. That's 2.5. All right, you guys, on this problem, which is equivalent to this? So you don't solve the whole problem. Some of you might see this and go, I got to solve this. No. All you had to do is distribute the 4, distribute to there. And 4 times x is 4x. 4 times 5 is 20. So we're good. -3 times x is -3x. -3 times 2 is -6. So A is actually the answer. We got 14. We distributed everything nicely. A is the answer. Everything distributes perfectly, and this is an equivalent statement to this. Equivalent means equal to, same as. If I want to find out what's equivalent to this, well, you're not solving it, but you want to look at the answers to give you an idea where you're going. So the first step is to distribute this. That would give you 8x, and 4 times -1 is -4. So the next step, when I have this, we look at the answers. Aren't the x's mostly on the right? So I would think my next step would be, let's add the 3x over. I now have 9 is greater than 11x minus 4. Does this match any of these? No. Wouldn't you get rid of this -4 to try to match one of these? How do you get rid of this -4? You add 4 to both sides. That gives me 13 is greater than 11x, which is which one? B. We do not divide. If we divided by negative at any point, divided, the sign would flip. We did not. So our answer is B right there. In order to find out what's equivalent, look at the answers. It looks kind of like what they're not solving it. But whenever you have a fraction equal to a fraction, it's called cross multiplying. So you multiply that, which is which one? Isn't it right there?
Yeah.
And then you multiply those, which isn't that right there? There's my answer. You don't even have to solve it. You don't have to do anything else. You just have to think which one does that step. Now, if I want to find out what's equivalent, I want to see which one of these, which one of these is the same as this after you do simplification. So depending on how far you have to go. So if you look at all these answers, it looks like the left side's the same for all these, isn't it? So all they're really doing is adjusting the right side. And what do parentheses like this mean? Distribute. So you're going to multiply that times that, which is 3x, having problems. And then 3 times negative 2 is negative 6. So does that look like this right here? The left side stayed the same, so it's C. Don't have to go any farther. There's no solving. Just find the step that's next. If I want to find what's equivalent, one of these is equivalent to this. The concept when you have a fraction equal to a fraction, you are going to do something called cross multiplying. So you're going to multiply added angle like that. That would be 5 times x plus 3 equals this. 8 times 2x minus 1. Now, does that match one of these?
Yeah.
No. We have to do one more step. What's the next step?
Oh.
Distribute this and distribute this, correct?
Yeah.
So when you distribute the 5, you get
5x.
5x. And 5x times 3 is 15. 8 times 2x is
16x.
16x. And 8 times negative 1 is negative 8. Do you see that answer somewhere?
Yes.
B. Cross multiply when you see two fractions equal. Alright, what's equivalent? Well, if you look here on the left side, did they simplify something over here on the left?
Yeah.
Yeah, and hopefully you noticed they did something called combining like terms. Won't those become negative 2x? A negative 4 and a positive 2 is negative 2x plus 2. So, what would be your possible answers? Is it A or B?
Yeah.
So could I cross off this and this?
Mm-hmm.
Now over here, aren't you going to distribute the 6, giving you 6x, and distribute the 6 and get negative 12? So do you see it's A? Because on the left side, that's what you got. On the right side, that's what you got. You got an equivalent expression or equation. Colleen solved the equation blank using these steps. To get from step 2 to step 3, Colleen did what? Oh, you know what? This problem, it looked like it might be a little hard at first, but all they want to know is how they got from this step to this step. So, to get from, didn't they just divide by 4
Mm-hmm.
and then reduce? That's all they want to know. So, wouldn't it be A? Now, I want to highlight something for you on this problem. You guys, if you look at this problem, watch this. Let's say you saw this on the CAHSEE, and then you figured that problem out. Could this help you on other problems on the CAHSEE?
Yeah.
If this is done properly, could this help you remember on this kind of problem? What is the first step they did from here to here? Could this help you?
Yeah.
Didn't they distribute the 2? Do you see how it can help? You solve a problem later on in the test. Then here, what do they do from here down to here? What's the step from step 1 to step 2?
They divided.
Didn't they minus the 10 over?
Oh, yeah.
They minus the 10 over. From here to here, divide by 4. That process, they just showed you how to solve a problem. And you could use that on other problems in the CAHSEE. Use that as an idea. Now, for the first thing we do is I got to simplify this side. In order to simplify this side to solve it, we are first going to distribute the 5, giving you 10x, and 5 times negative 3 is negative 15. And then I'm going to rewrite everything else around it. Now, is this side simplified? No. You are allowed to combine these two x's. What's 10x and negative 6x? What's 10x and negative 6x would be 4x. So we combined these two, got 4x. Now to get this, so it's just x on the left side, I got to get rid of this. So what's the opposite of minus 15? We're going to add 15 to both sides, canceling, leaving us 4x over here, less than, and 9 plus 15 is 24. Last step, to get the 4 off the x, I have to divide it off, so we're going to divide by 4. My final answer is x is less than 6, which is right there. Now, another way you could have done this, and maybe got lucky. Ready? Did any of you think of just taking each of these numbers and plugging them in for x?
No.
And see which one would equal 9? Even though with the inequality it technically doesn't always work, you could try it. Because watch, if I put 6 right there, what do you get? 2 times 6 is 12. What's 12 minus 3?
9. Oh, wow.
Got it? So that would be 12 minus 3 is 9. What's 5 times 9? That would have been 45. And what is 6 times 6?
36.
So it would be minus 36. Does that equal 9? You could have plugged numbers in on this one. Yes, with inequalities it doesn't always work, but you could have plugged in. You plugged in any of the other ones, it would not equal 9. Now, yes, again, that's a less than, but if you just want to find the digit of all of them, since they're all different, you could find the digit is 6 by plugging in the answers and seeing which one equals 9. It works the same way. If we're going to solve this, it looks really creepy, but technically, since these are all plus, you're just going to combine everything. So you kind of just drop the parentheses and combine the x's. There's a little 1 there. How many x's would that be when you combine all those? 11 plus 6 plus 1 is, isn't that 18x? Next, you combine the 2, the 4, and the 5. What's that give you? What's 2 plus 4 plus 5? And then you just rewrite the other stuff. Is that an easier problem now? Hopefully so. Hopefully you know you minus the 11 off. So I have 18x is greater than 90 minus 11. Hopefully you know is 79. Then how do you get rid of the x off the 18? Sorry, how do you get the 18 off the x? You divide by 18. That will cancel that. Now you might go, oh man, I don't want to divide that. Do you have to? Isn't that right there? Yeah. Look at the answers. It's right there. We didn't divide by any negatives. No signs flipped. We're good. For the y-intercept, I want to find the y value. Okay? So y-intercept, if I want the y value, your x is 0. So what you're technically going to do is put a 0 here for x, which basically means, can I just cross that out?
Yeah.
Aren't I just always just going to cross this out right here and solve this right here? So divided by negative 3, y equals negative 4. Which of these coordinates have a y value of negative 4? Isn't that x equals 0 and y equals negative 4?
Mm-hmm.
Now, could you technically just take each coordinate and plug them in and see which one actually exists? But you might get 2 answers. Because one of these could be x-intercepts. These could be your x-intercepts. And really, actually, this is your x-intercept. If you want your x-intercept, do you understand you're going to get rid of y
Yes.
and solve for x? So this is actually a coordinate. This is x-intercept. This is your y-intercept. Be aware. If I want my x-intercept, I want the x value. So what's y going to be?
0.
0. So isn't that basically going to disappear?
Yeah.
So 3 times what equals 12?
4.
Oop, divided by 3. The answer is 4. Okay, so it's, how do I know which one it is?
Because it's for the x, not the y.
X is 4. Is x 4 right there?
Yeah.
And like I said, isn't y 0?
Yeah.
There it is. Be careful. What would be the y-intercept? When I get rid of this and solve this, wouldn't it be y is 3? Wouldn't it be a?
Yeah.
The y is 3 would be your y-intercept. If this is your equation, all right, 1/2 is your slope. Remember, y equals mx plus b. So 1/2 is your slope, and 2 is your y-intercept. So which one of these crosses at 2? Does this cross at 2 right there?
No.
No, okay, cross that one out. Okay, this one crosses at 2, we're good. This one crosses at 2, good. This is negative 2, so I can cross that one out. So out of the 2 choices here, which one of these has a slope of 1/2? Meaning it goes up 1 and over 2. This one goes up 1 over 1, huh? This one goes up 1 and over 2. Can you see that's the answer? Because it goes up 1 and over 2, and it begins at 2. Begins at 2, up 1 over 2. It's a little packaged answer. Slope, y-intercept. X equals 3. Which of these lines cross the x-axis at 3 is basically what you want to know. Isn't that x equals 3 right there? So which one of these graphs cross x equals 3? Isn't this the one that crosses at that point x equals 3? None of the rest have a value of x equals 3. So the answer is A. X-equal graphs are always vertical. If I want my y-intercept, don't I want y?
Yeah.
So don't I put 0 right there? So won't that disappear?
Yeah.
So when I divide both sides by 4, what do I get?
A. 3 over 4.
So what's my y-intercept? 3/4. If I wanted my x-intercept, wouldn't you put 0 right here? Wouldn't it be 3?
Yeah.
That's your x, and that's your y-intercept. If I want to find the point that lies on this equation, you simply plug each one of these in. This is your x, this is your y. Plug all of them in. When I plug in the first one, this goes right here, and this goes for x. So does -4 equal -4?
Yes.
Well, yes, it does. So that's the answer. If you try any of the others, if you put -4 here for x and 4 for y, they're not the same. All the rest, when you plug in, is a false statement. It's kind of nice that that first answer is true. It keeps you from having to go any farther. Oh, I love that when that happens. Which of the following point lies on this equation, this line? What we do is take each point and plug them in. So let's start with the first one. This is your x. This is your y. So I'm going to put 0 right here. And I'm going to put 4 right here. So 4 times 0 is 0. Plus 5 times 4 is 20. Hope that little thing doesn't show up. I don't think it will. Alright. If I want to see which of these gives me this line, what you could do is rewrite each of these so you get into y equals mx plus b form. You could rewrite all these as y equals. But for you, I've noticed it's kind of tough. So for me to tell you to rewrite all these into slope-intercept form would be a nightmare. Here's another way. Ready? I'm going to try this way. I think it's be easier. Look at the graph and find a coordinate. Are you guys okay? There's a coordinate right there. And what is that coordinate called? Do you understand that coordinate would be 3, 0? Is everybody okay that that coordinate is 3, 0? Now what I'm going to do, can I put 3, 0 into all these and find out which one's true? Could I put 3 plus 2 times 0, does that equal 3? Yeah, it does. So could it possibly be A? Next, go to the other one. 3 plus 2 times 0, does that equal 5? What's 2 times 0? 0. So is 3 plus 0 equal to 5? No, can I cross that one out? That one does not go through 3, 0. Let's go to the next one. 2 times 3 plus 0, does that equal 9? Does 6 plus nothing equal 9? No. So that one doesn't work. Alright, hopefully this is kind of making some sense, what I'm doing. The next one, okay, 4 times 3 plus 2 times 0, does that equal 3? Does 12 plus nothing equal 3? So, do you got my answer? That is the only line, you guys, that goes through that point. And that point is 3, 0. So all you do is look at your graph, find a good, easy point, preferably something with a 0. Plug it into all of them. Since these 3 do not land at 3, 0, I know that's my answer. Now, if 2 of them worked, you then choose a different point. So I would maybe choose this point right here. See that one right there? I'd probably put negative 1, 2 in to the 2 that are left over. For instance, if 2 of them worked, you have to put a different number, different coordinate in and see. This is some way to solve it. I think it's easier for some of you. If I want to find line parallel, the slope of a line parallel to this, first, which is the slope? The 1/3 or the 2?
The 1/3.
1/3.
So that's the slope. Now, parallel means this. If two lines are parallel, they have the same slope. So which is that? For two lines to be parallel, they have the same slope. So bam, there's my answer. Which of the following is describes parallel lines? Do parallel lines have the same y-intercept but different slopes? No, the basic idea of parallel lines, don't they look like that? Don't they have the same steepness?
Yeah.
They have the same slope, so that's what we're looking for. So don't we have the word here, same slope? Do we see same slope anywhere else?
No.
Now, these two lines would also have different y-intercept. If I put my x-axis there, doesn't this one cross there and this one cross there?
Yeah.
Parallel lines have the same slope but different y-intercepts. That's the exact definition of parallel lines. You guys, if I want to find parallel lines, that's a really big pointer, you look at the slope. So your slope is 4. Which of these has the same slope as that? Because parallel lines have the same slope. Can you tell that B here has the same slope? All right, the slope of a line parallel to this. Now, to have a line parallel to this, you know it's going to have the same slope. So basically, the question is asking, what is the slope of this line? Now, right off the bat, you can cross these two out because you can tell this is a negative slope. Second of all, you got to find points where they intersect. So can you see that's an intersection point, and that's an intersection point, and there's another intersection point. Can you see those are kind of nice intersection points where the line crosses the kind of, I don't know how you describe it, basically intersect, where the lines intersect the x and y lines. Anywho, then you go, okay, you got to measure this. What's your rise over run? Well, if we notice that's 2, and that's 3, and it's consistent between all those red dots. So is it, my question then is it 3 over 2, or is it 2 over 3? Well, it's rise over run. And which one's the rise? The 3. So wouldn't it be A? Downhill, and it goes down 3 over 2. If I want to find the solution to the system of equations right here, you're going to simply plug each coordinate in until you find the one that works. There is a method called elimination or substitution to solve these, but all we're going to do is, this is x, this is y, and we're going to plug them in. So 7 times negative 2 plus 3 times negative 2 equals negative 8. Is that true?
No.
Does that, which is negative 8 plus negative 6, does that equal negative 8?
No.
So can I cross that out? The first one didn't work. Okay, let's try the second one. So I have 7 times x, which is negative 2, plus 3 times y, which is 2. Does that equal negative 8? Let's see. Is that negative 14 plus 6? Does that equal negative 8? Are we good? Does that work? Does that equal negative 8? I think so, right? Okay, it works for that one. Let's check the other one. Okay, for the next problem. Negative 4 times negative 2 minus 2, does that equal 6? Well, what's negative 4 times negative 2? Isn't that 8? Does 8 minus 2 equal 6?
Oh my.
Does that work?
Yeah.
There it is. Could I keep going to check? Could I try these two?
Yeah.
In case I made a mistake. Yeah. But I'm pretty confident in my work, so that should be the answer. If I want to find the solution to the system looks a little different. You still go through and plug the coordinates one by one. I'd probably start with these smaller numbers first. So this is x, this is y. So I go up here. You have y and x. So I'm going to put negative 2 for y and 1 for x, which is negative 2 equals 3 minus 5. Is that true?
Yeah. Oh wait, no.
Does negative 2 equal 3 minus 5? It actually is. That is correct. So it's right so far, but let's try the other one. If I put negative for this one, if I put negative 2 for y equals 2 times x, which is 1, is that true?
No.
Does negative 2 equal 2?
No.
No. So I could cross that one out. Now, I'm going to go to the answer because I know which one it is. I know the answer is C. You'll see why in a second. I'm going to plug it in. C. This is x. This is y. So watch. For the first equation, 10 equals 3 times 5 minus 5. So 10 equals 15 minus 5. Does 10 equal 15 minus 5?
Yeah.
That does. So good. Go to the other one. So y is 10. X is 5. Is that true? Does 10 equal 2 times 5?
Mm-hmm.
So it's true for both, so that is the answer. Kind of jumped to the answer, but you could test all the rest, but C would be the solution. You just got to try them until you find the one that works. Alright, you guys, if I want to find out these equations, which one of these graphs are these two lines? Well, what is the y-intercept of both of these?
3.
3. So don't they both cross at 3?
Yes.
So that's 3, but this is negative 3. So could I cross this one out? Okay, that's 3, but that's negative 3. Can I cross that out? That's negative 3. I'll cross that out. Oh, what's left? Do they both cross at 3? Does one of them have a negative slope? Does one of them have a positive slope?
Yeah.
Could we also cross out these two because aren't they the same slope?
Yeah, parallel line.
And here, isn't this one negative, one positive?
Mm-hmm.
So right away we know these aren't the answer because the slopes here are one's positive, one's negative. So right away you could know this by the slopes. You'd also know by the y-intercepts. In the end, there's your answer because one slope of negative 1 and starts at 3. That's this one. And the other one starts at 3 and slope of 1. It's that line. It wants the x-coordinate of the solution. So if that's x, watch this. Could I simply, let's say, start with this one right here. Could I start with this one right here and plug negative 2 in for it?
Mm-hmm.
So I have 2 times negative 2 plus 3y equals 7. Could you solve for y? Watch this. Isn't that negative 4 plus 3y equals 7? Add the 4 over. 3y equals 11. Divide by 3. Great. Y equals 11/3. Now, when you plug in negative 2 here, will y equal the negative? Does it have to be that same y value?
Yes.
If I plug for x negative 2 here, you wonder, will I get 11/3 out? And if you did, you would not. But that's what you do. You plug this number into both of them and see if they come out with the same result.
And that's
A
it?
little bit different, yeah. You plug the x into each one and see if the y value is the same for both. And when I plug in negative 2, you would not get it for the second one. So let's try negative 1. So we cross that one out. The next one, okay, 2 times negative 1 plus 3y equals 7. That's negative 2 plus 3y equals 7. Add the 2 over. And 7 plus 2 is 9. So what's y equal? When you divide by 3, y equals
3.
So that's this one. Let's try the second one. Kind of running out of space, aren't I? 3 times 3 minus y, does that equal 5?
No.
It would not work. So you keep going. So one by one, we plug the numbers in for x and see if they both get the same value for y. That is a way to do this. Now, so here we go. Let's try 1. 2 times 1 plus 3y equals 7. If I do this, I'll minus the 2 over because that's going to be a 2. So 3y equals 5. Y equals 5/3. I'm running out of space. When you do this one, okay, when you plug in 1, you would not get 5/3. So you go to the next one.
So it has to be B.
Well, out of what's left, it ends up being D, okay, because none of the rest work. Quote, okay. When we want to simplify this, we are going to subtract x squared, 2x, and 7. Now, an easy way to write that as subtracting all three of those, here's what I like to do. I like to simply just rewrite the first piece. Okay, I like to rewrite that as is. But then I like to, instead of doing the opposite of each of those, so I'm going to subtract x squared, I'm going to subtract 2x, I'm going to subtract 7, or do the opposite of each one. So what do you get when you combine those? Don't they cancel each other out?
Yeah.
When you combine those, I put 2 lines underneath them. What's negative 3x and a negative 2x? Is that negative 5x? And then I'll put 3 lines under the numbers. What's 1 and negative 7?
Negative 6.
So can you see C? Yeah. Alright, you guys, I want to find the area of this with this length and width. This is area right here. Area is length times width. So basically all we're going to do is take the length, which is x, times the width. Okay? You're just multiplying the two. Now you did this a while back. How do you multiply these? It's called distributive property. So what's x times x?
X squared.
X squared. What's x times 6?
X equals 6.
6 times x. X times 6 is 6x.
Yeah.
Do you see that answer somewhere?
Mm-hmm.
Done. To simplify this, you're taking 2x and dividing each piece by it. So you're going to have 4x cubed over 2x plus 2x squared over 2x minus 8x over 2x. So, right here, 4 divided by 2 is 2. And if you subtract the powers, and they're like a 1 power here, 3 minus 1 is 2, so it'll be x squared. Isn't 2 over 2 cancel?
Yeah.
And then right here, what's 2 minus 1?
1.
So 1x. Do we know the answer already?
Yeah. Yep.
But let's do the last one just for kicks. Divide the x's out, that cancels. And 8 divided by 2 is?
4.
You guys, you hopefully noticed you could have stopped right earlier, but you just want to simplify each one just to make sure. Take our time. For this problem, Mr. Jacobs does 150 quizzes in 50. The aide does 150 in 75. How long together for 150 quizzes? The basic idea is first look at Mr. Jacobs. If he does 150 in 50 minutes, that means that Mr. Jacobs, Mr. J, can do 150 per 50. That would be 3 quizzes per minute. His aide can do 150 in 75, so that would be how many? 2. Now if they work together, wouldn't it be 3 plus 2, which is 5? And we want to do 150 quizzes, so let's just simply look at each answer. If I did 30 minutes, 30 minutes at 5 per minute, what's 30 times 5? Hey, it's 150. Is that the answer? In 60 minutes, that is the answer, but what would 60 be? 5 times 60 would be 300.
Yeah.
They did way too many. So all they would need is 30 minutes working together to do this, if that was correct. This is kind of a tougher one. He runs 10 miles each Saturday. That really doesn't matter for this question, you'll see. If he doubles his usual speed, he can run 10 miles in 1 hour less than his usual time. That is a very confusing statement. What is his usual speed? So these are, what do these numbers represent? His usual speed. So let's just choose one of them and test it. Actually, let's just choose the answer and we'll show you how it works. The answer is D. This is going to be easier. I'll tell you why. It's easier than working backwards for every single one. It's quicker. If he runs 5 miles per hour, what would double his speed be?
10.
Would that be 10 miles per hour? Are we okay with that? Because they say double his usual speed. So how long would he take at 5 miles per hour to run 10 miles? Wouldn't that be 2 hours? If you're running 10 miles per hour, how long would it take to run 10 miles? 1 hour. Okay. Now, the question is stating he can run 10 miles in 1 hour less than his usual time. Is he running 10 miles an hour less than this? Is that a difference of an hour? Yes. So that is the answer right here. If you tried the same process, if I said this was 2 miles per hour, what would this be? Wouldn't that be 4? If I said this was 3, wouldn't this be 6? And if I did the process to each one, none of them would be a difference of an hour except for this one. This would be the only one with a difference of 1 hour. Yoshi has exactly $1 in dimes and nickels. She has twice as many dimes as nickels. How many nickels does she have? So these numbers represent nickels or dimes? These represent nickels. So if I have 4 nickels, how many dimes do I have if I have $1? 4 nickels is how much money?
20 cents.
Isn't that 20 cents?
That'd be
So don't I need this to be 80 cents?
8
To be $1. So how many dimes would that be?
8.
Let's see if that fits the scenario.
That's twice as many.
Now the question says here, Yoshi has twice as many dimes as nickels. Does she have twice as many dimes as nickels?
Yes.
Oh, so is that the answer?
Yes.
That is the answer, so we can stop. All you got to do is one by one do the problems until you find the one that works. Don't worry about any kind of crazy other stuff. Just do one problem at a time and see if it makes any sense. All right, Diane delivers newspapers, $5. Yeah, nice. And then it's much per newspaper. Jeremy, not as good, but a lot more per paper.
I would like.
The question is, when do they both get the same amount of money? How many newspapers? So what I would do is plug the answers in one by one. So I go to 30. Okay, 30 newspapers at 4 cents each. If you think about that, that's 0, that's 12. Is that $1 or 20?
Yeah.
Plus the $5 initially. So how much did he make there? 620. Now the other one at 30 would be, let me see, 30 times 10 cents would be 0, 0, and then 0, 0, 3. So it'd be $3 plus what? Plus the $2 initial. What does that equal? Does $5 equal, do these equal? Is 620 the same as $5?
No.
So that is not an answer.
So it's not A.
So it's not A. Let's go to the next one. 50 newspapers. Okay, so 50 newspapers at 4 cents each is, looks like $2. Plus the $5 is $7. Alright, let's try the other one. Let's see what we get here. The other one's going to be 50 newspapers at 10 cents each. That's going to be $5. Plus the $2 initially, $7. Are those the same?
Yes.
They're the same, so there we go. Now, if this was me choosing a job, if my route has less than 50 newspapers, who has a better route?
Diane.
If the route has less than 50 newspapers delivered, Diane has a better route. But if there's more than 50 newspapers delivered, who has the better route?
Jeremy.
Jeremy. I would say both of these are way underpaid. Is $7 very much?
That's not even a wage.
Or 6? I mean, yeah, it's not very much. You better hope this is a big route. So in the end, isn't Jeremy's way better?
Yeah.
Because in the end, I wouldn't even take Diane's job. I want to work all this time and get less than $7. It's like, that's dumb. I want Jeremy's job.
I would take.
All right, the student store sold 55 shirts and made this much. Red shirts and white shirts. Reds were $12, $10 for whites. How much for each color shirt? Sorry, no. How many of each color? So what we do is we plug them in one by one. I'm going to start with D. Let's see if D works. Okay, so if I do 35 red shirts, so that'd be 35 shirts at $12 each. When you do that, you get 10. Okay, that'd be 7, 0, 5, 3. So that looks like it will be $420. All right. Now we'll try white shirts. So that'd be 20 at how much each?
$10.
That's an easy one, huh? Can you see that's 200? So you have $200 and $420. What do those add up to?
720 or 620.
Do those add up to the 620 I want?
Yeah.
All right. So that's our answer. Now, I didn't know that was the answer beforehand because we talked about that.
I knew that.
But
Too.
could you do each problem one by one? Could you do the same thing for each one?
Yes.
Because together you want these two numbers add up to 620 and just do 20. Okay, 20 at $12. 35 at $10. Do they add up to 620? They would not because we just showed you D works. All right. Very kind of practical problem.